We have been learning about relational data. That is, data in one data set that is related in some fashion to data in another data set. The primary reason that we need to learn about relational data is because we often have to merge data sets, or at least portions of data sets. We're going to talk about joining data from two data sets. We're going to start with the concept of mutating joins. A mutating join is a way of combining data sets based on a key. Now, there are three primary mutating join types. First, an inner join. That matches observations with equal keys and only includes matched rows in the results. An outer join keeps observations that are in at least one of the tables. A left join keeps all data in the left data set and adds variables based on the right data set. This is by far the most common join. A right join keeps all data in the right data set and adds variables based on the left data set. A full join includes all variables from both data sets. And then finally, we have a natural join, which uses all variables that appears in both tables. Okay, at this point, you're totally confused. So what we need to do is take this one at a time and give you an illustration. So let's start back here with an inner join. That matches observations with equal keys. Remember, we were talking about primary keys and foreign keys, and only includes matched rows in the result. So let's look at a diagram. Let's focus here on the left because that's illustrating an inner join. So with an inner join, what we're doing is we're taking the key from the data set on the left, indicated by this little rectangle, and the key is indicated as this 1. We're looking for a match in the other data set, the second data set, indicated by this little rectangle on the right. And when we find a match of the keys, then we take the variables from both data sets and create a new data set in which we're matching or including both of those variables from that matched key. If we take the left data set and look at 2, that also is a match. So now we're taking the value x2 and y2 and putting that in the data set. If you look at the key 3, there's no match found over here on the right. So that's not included in our data set. And if you look at 4, there's no match on the left. And so that's not included in the data set. So let's look back now and see if it makes more sense when we read the definition of an inner join. An inner join matches observations that have equal keys and only includes matched rows in the result. So here, the matched rows were the first and second, and so the data from the left data set and the data from the right data set are combined only for those first and second values. So when you only want to use data in which you find a match in both data sets, that is referred to as an inner join, and all other rows are eliminated. The next type of join is an outer join, and we see we have 3 different ways of doing an outer join. So let's look at all 3 ways. Starting with a left join, and this is very much worth knowing about because it is, as I mentioned here, by far the most common join. What a left join will do is keep all the data in the left data set and just add to it from the right data set. Here's an example here right at the top on the right-hand side. So here's the left data set and here's the right. So what we know is that all the data in the left data set is going to be included. So what we're looking for is, can we find a match over here in the right? And if we can, we add that variable to our new data set. So here we have joined row 1 because there was a match and we have x1 and y1. Row 2 because there's a match and so we have x2 and y2. Row 3, we did not have a match, but this is not an inner join. If it was an inner join, we wouldn't include row 3. This is a left outer join. And so we keep row 3 from the left side here, even though there is no match of the key over here on the right. And since there's no match, that becomes missing on our new y variable. So here is row 3. We have kept x3. So if you look at the key and value x, that's just everything that appeared in the left data set. Now we've added the y column to this data set, except that there was no match here, so this is missing. Row 4, or key 4 over here is only in the right data set, and so it's not included because remember, we're only keeping what's in the left data set. A left join keeps all data in the left data set and adds variables based on the right data set. And a right join keeps all data in the right data set and adds variables on the left data set, which you probably now feel that makes more sense without even looking at the diagram. Here's the right join. So what we're doing is keeping everything here that's on the right. So notice y1, 2, and 3 are all going to be kept. Notice the keys for those, 1, 2, and 4, they're all here. We found a match for 1 and 2, so x1 and x2 are here. And we did not find a match for key 4, so that becomes an NA for x. So that is a right join. In terms of outer joins, the final type of outer join is a full join. That includes all variables from both data sets. So if you look here, we have x1, x2, x3, we have y1, y2, y3. They're all going to be included here. And how they're included simply depends upon whether we can match keys. So when we can match keys, everything's fine, x1, y1. For key 2, everything's fine, x2, y2. For key 3, we couldn't find a match over here in y, so we're putting in x3 because we're including everything from both data sets, and we're just going to have to put in NA, missing data, for key 3 for value y. And for key 4, which only appears here in the right data set, we're going to have y3 still in our data set, but we didn't find a match for x, so that becomes an NA. So here are the 3 outer joins, left, right, and full. Then the final type of join is a natural join. And a natural join uses all variables that appears in both tables. What we mean by that is we don't specify a particular key. Rather, if we're doing a natural join, we just ask for a natural join, and it can be any of these types, inner, left, right, or full. But we ask for a natural join without specifying matching variables or keys, and what it uses as our keys is any variable that appears in both tables. Okay, so if we were, for instance, to ask it to join flights with planes, The only variable that appears in both of these is tail number, so that's going to be used as the key. So no key is specified. It will use all the variables that match. If we use weather, it's going to match based upon year, month, day, hour, and is that it? No, origin. Origin is here as well. Year, month, day, hour, and origin. So it's going to match based upon those. Now, how it matches depends upon how we ask for the natural join. For instance, if we're asking for an inner natural join without giving a key, that's what makes it a natural join. So if we ask for an inner join without telling it the key, it's going to automatically use year, month, day, hour, origin, and because it's an inner join we're asking for, it's only going to include those rows in which you have the exact same year, month, day, hour, and origin in both data sets. So most of the time, what we'll do is we will be specifying. So we don't need to think too much deeper about natural joins. It really just refers to as joining when you don't tell it which key to join on. Okay, so that is the concept of mutating joins. In the next part, I will give you some examples of mutating joins.